Good morning, student. I am Dr. Ritika, faculty of CSC department, as an associate professor in St. Andrews Institute of Technology and Management. Today, I am going to deliver the lecture on the subject of software engineering, which is related to your BCA 4th SEM. And today we will cover the topic of our debugging, which is related to our unit 4. So today we will learn more about our debugging and their debugging approaches and some activities which is related to your debugging, in which we will cover how debugging process is to be done. So lot of things we will cover related to our debugging in our slide. So let's start, students, learn about debugging. Now, introduction. Debugging is a methodical approach of finding and reducing the number of bugs or defects in a computer system, thus making it behave as expected. Debugging is a process to start with the problem, to isolate the source of the problem, and then fix it. This is known as the process of debugging. Now, next introduction part is debugging occurs as a consequence of successful testing. That is, when a test case uncovers an error. Debugging is the process that results in the removal of the errors. So, debugging has the objectives to find and correct the cause of a software error. Now, what is debugging? Bug and debugging are attributed to the discovery of a moth found in a Mark II computer at Harvard University. So, debugging is not troubleshooting. Now, here are some simple methods of debugging are: first is start, second, construct a hypothesis, third, construct an experiment, fourth, hypothesis proved, or you can say go to. Next process is need more evidence, and last is the stop. So these are the debugging process or method which follow different processes to find the bug or to follow the method of debugging in a software engineering. Now, debugging process. Debugging process is done by following methods, like first is test case, then execution of cases, then before execution it gives the result. After result we will start debugging. Debugging to be may be classified into different forms, like suspected cause and additional test. They find debugging and send back to their again test cases, or we can say debugging after doing the debugging in a software engineering, they can identify causes, corrections and regression test and moves to the test cases. So debugging process is done from test cases to the result, and after result we will start debugging on the various different processes, like suspected cases, like identified cases, causes, additional test, corrections, and again we will apply the regression test. So on the basis of this we will start debugging process. Now, the debugging process begins with the execution of a test case. Results are accessed and a lack of correspondence between expected and actual performance is countered. So, the debugging process will always have one of two outcomes. The cause will be found and corrected, or the cause will not be found. So, in this case, the person performing debugging may suspect a cause, design a test case to help validate that suspicious, and work toward error corrections in an iterative fashion. So this is the process which I have tell you, which is based on this process also. So next is the debugging versus testing. So what is the difference between debugging and testing? It's very interesting question according to your examination point of view or an interview point of view. what is the difference between debugging and testing? So debugging is carried out by the development team or developers after getting the test report from the testing team about defects. But but in testing is to show that the software works or does not work with intentions to increase software quality. So here is the difference between debugging and testing. So let's learn more about in a tabular form difference between testing and debugging. Now first point in testing is finding and locating of a defects. First point in debugging is fixing that defects. In testing is done by testing team and debugging is done by development team. In testing, intentions behind is to find as many defects as possible. In debugging, intention is to remove those defects. So, it is a difference between testing and debugging. Testing is not debugging and debugging is not testing. Lot of difference between debugging and testing which I have shown in tabular form in a very easy language. So finding and location of a defect and fixing that defect is debugging. To finding that defect is testing. It is done by testing team and it is done by some development team. So it's in testing main intention is to find many defects as possible. But in debugging, main intention is to remove those defects. Now, debugging methods. First method is print or trace debugging, watching the flow of execution after adding print statements to the original code. Remote debugging is to connect to a remote system with a debugger, monitor the execution and the state. The post-mortem debugging which analyze of a memory dump from a program that has crashed. Profiling means not debugging per se but a useful technique for analyzing a running program to look for issues. Now some debugging approach like brute force methods, backtracking methods and cause eliminating method. So each of these above debugging approaches can be supplemented with debugging tools such as debugging compiler, dynamic debugging aids, automatic test cases generators, memory dumps and cross-reference maps. So these are the debugging approaches. Now first is the brute force method. The most common and least efficient for isolating the cause of a software error. A printout of all register and relevant memory locations is obtained and studied. So all dumps should be well documented and retained for possible use on subsequents. It also involves using the debugger to step across the code from start to finish until you notice something odd. Here are the process a bug is reported. If you do not see the problem, then step over code for start to finish. It moves step over code from start to finish. If you do not see the error or the bug, it will move to the next step. If same thing, if you can see the cause, it fix the awareness and if you fix the error, then it will goes to end. But if in this step, that is first, second, third, fourth step, if you do not find the bug or you are not going to fix the bug, it's again move to step over which may start the code from starting to finish and then see something, but it again fix the bug and moves to the previous or upcoming steps. So these are the step by which you can find out the bugs, you can fix the bugs. If any case, if you ignore the bugs, you can move it over the, or you can say step over the next step and then fix it again, and you will end the steps. Now next is the backtracking methods. It is a quite popular approach of debugging which is used effectively in case of small applications. So the process starts from the site where a particular symptom gets detected. From there on, backward tracking is done across the entire source code till we are able to lay our hands on the site being the cause. So unfortunately, as the number of source lines increases, the number of potential background paths may become unmanageable large. Now third is the cause elimination. The third step is the cause elimination, which is latitude manifested by inducting or deductions and introduce the concept of binary partitioning. So data related to the error occurs are organized to isolate potential causes. A cause hypothesis is devised and the data are used to prove or disprove the hypothesis. Alternatively, a list of all possible causes is developed and tests are conducted to eliminate each. So, if initial tests indicate that a particular cause hypothesis show promise, the data are refined in an attempt to isolate the bug. So here are some different debugging rules, like understand the system, next make it fall, next quiet thinking, next divide and conquer, next change one thing at a time, next keep an audit trial, seventh check the plug, eighth get a fresh view, and ninth if you didn't fix it, it is not fixed. So first is understand the system. So know the fundamental of the system, understand the framework involved, read the API and communication interface, know your tools, also understand what each module of the system does. Second, make it fail, start at the beginning, automate the failure, no detail is insignificant, intermittent intermittent failures, and isolate the failure. Quiet thinking and look, gather the low level details and see the failure. Understand the context of the bug. Design instrumentation and runtime status messages. Debug logging. Be descriptive. Deployment time, environment checks. And last is a hypothesis and test. In fourth, divide and conquer is a narrow search down software and hardware, which is a successive approach to start at the bad end or error log and work your way up the chain looks at the various points on the way. So fix the bugs you know about fixing. One could fix the other, and fix the noise first, but do not go nuts. Next, change one thing at a time. Here, compare with a good one. Use a rifle, not a shotgun. What has changed recently is used to work. Separate environment and product. In next step, keep an audit trial. During debugging, write down what you did, in what order, and what happened. So be specific and consistent. Correlated symptoms with others. If versions controls and change logs are great for determining an audit trial of what is changed. Check the plug means questions you assumes. Eighth, get a fresh view means get another view on the solution. Talk to somebody about the problem. Ask an expert, like email the author. Check the forms. Subscribe to the mail list. And last is make sure you report symptoms, not theories. Next is the if you didn't fix it, it isn't fixed. So most important lesson by far is fix the root cause. Make sure it cannot possibly happen again. Fix the process at fault. So we didn't see an issue until we deploy into the production environment, which is equal to the deploy early and deploy often. So these are the steps by which debugging approaches are to be done. So debugging methods and tools. Now, lesser known debugging methods like rubber duckling, which explain your problem to someone else, starting the problem aloud in order to work it out. Next is the fail first. Write a unit test that expose the failure, correct the code and make it pass. Now, soft squeeze means write a system test, inline code, write test, repeat until fix. Next, Chezo monkey means AWS Netflix approaches, randomly kill and test areas, also fail consistently to test fault tolerant softwares. Now, Eclipse debugging 1, which set breakpoints in the code, step into overreturn, watches display a variable value hit counts, setting an exception breakpoints, and next is setting a method breakpoints. Now in Eclipse debugging 2, class load breakpoints, using display after a breakpoint has been hit, attaching a remote debugger via a GDB agent. Now next is bugs taxonomies and bug types. So there are a way to categorize bugs. Lot of taxonomies available for research literatures. So some bugs type include Bohr bug and Hazen's bug. So in Bohr bugs, bug that manifests itself consistently under a set of conditions. In Hazen's bug, that alters its characteristics when studied. Now preventing bugs. So debugging is hard and expensive in terms of fixing the bug, testing it and redeploying it. So we can try and prevent bugs with code review, defensive programming, precondition, postcondition and invariant checking assertions. These are the different steps in which you can prevent the bug. Now next is the further resources, means debugging 8, and debugging the 9 indispensable rules for finding even the most elusive software and hardware problem, which is done by David Engg. Debug 8 means find, repair and prevent bug in your code or pragmatic programmers, done by Paul Butchers. Now testing educations, I have given some link. Lars Vogel's debugging review, I have given some links by which you can learn more about testing and debugging. Now students, it is all over about our testing, all over about our debugging approach, debugging processes, debugging methods. So we have covered all debugging approaches, some activities related to your debugging in our slides. So students, thank you very much for your kind attentions. Have a nice day. Thank you students. So student, it is all over about our unit 4. Now syllabus is completed from my side. Now further we will move to the previous year question related to our software engineering. So we one by one we will cover. I will try to cover according to unit wise, or I will try to solve all question paper related to your MDU with their proper solutions. So follow up students, it will be very helpful for your examination. So saying thank you students. Once again thank you for your kind attention. Thank you students.